Parallel lines, perpendicular lines. Here we go. Determine which of the lines, if any, are parallel. So first thing I will just say, parallel lines have the same slope. Okay? So what we're going to do is we're going to zoom in here, and because we literally have a graph, I'm just going to do rise over run. That is slope. Actually, I pointed the same. That is slope, okay? So for the blue line, it looks like we rise 1, 2, run 3. So that's 2/3 because it was +2 and +3. For this red line, that's pretty easy because it's rise 2, run 3. That's also 2/3. And the green line looks like we're going to rise 1, 2, 3. So 3 over 1, 2, 3, 4, 5. Oops, looks like the green one is not parallel. So it's going to be lines. Oh, I see. There's an A there and a B there. A and B, because the slopes are the same. Which lines are parallel, if any? So what we need to do is find the slope. So how do you find slope? You could graph these, or you could just do the slope equation, which is y2 minus y1 over x2 minus x1. I prefer to kind of do this in my head if I can. So like 0 minus -2, that's 2. 1 minus -1, that's 2. So our slope for A is 1. -2 minus 2, that's -4. 2 minus 4, that's -2. Well, -4 over -2, that is 2. And then this last one, 1 minus 2, that's -1. -1 minus 0, that's -1. So this is 1. So it would appear that it's A and C because the slopes are the same. That says sane, but we'll go with it. Which of these are parallel? Well, they will have the same slope. Now, the fastest way for me to find slope when it's in an equation is slope-intercept form, because the slope will be in front of the x. So you might think, oh, well, the slope here is 1. That is not how that works, because we want y to be by itself. So what I'm going to do is I'm going to subtract x from both sides and get 4y equals -x plus 8. I'm going to erase this line real quick so you don't think that that negative is pointing to that m, because it's not. I'm going to divide by 4. And I get that the slope here, the slope for line A, is -1/4. Okay. So now I'm going to zoom out so I can do some of my math maybe over here. 2y plus x equals 4. I'm going to subtract x. I'm going to divide by 2. That slope is -1/2. So it's definitely not line A and line B. Line C, 2y equals -3. You know what? We don't even have to really write this one out, because we could have divided by 2 in our heads to get this. And the slope of this one is -3 over 2. So the answer is none or nada, because the slopes are all different. None of those slopes are the same, and they need to be the same to be parallel. Write an equation of the line that passes through this exact point and is parallel to this exact line. Okay. We did one in class today where I gave the equation like here. Let's do it for this one. Here's the slope of that line. So here is an equation of a parallel line. This line is parallel to this line as long as B does not equal 2. That 2 in particular. Why that 2 in particular? Because if it was that 2, then this line would not be parallel. It would be the exact same line, right? Well, we want to go through a particular point. So what we can do is we can either plug this in here and solve for b, or we could do the point slope form, which is y minus y1. So here's what we could do. I'm actually going to do the purple thing first, and then I'm going to do the blue thing, just to show you both. So here we go. This is y, hey, hold up. I'm going to rewrite it real quick. And then what I'm going to do is I'm going to plug all that in. So our y here is 3. 3 equals negative 3 times negative 1 plus b. This is 3 equals positive 3 plus b. Well, solving for this, we subtract 3, and we get that b equals 0. So really, this is 0. So the answer, we know the answer is going to be y equals negative 3x. That's the answer, okay? And I did it this way because, well, I knew the slope, and I can plug in that point if I wanted to. In fact, I asked in class today if people wanted to see how this was done, and everyone said no. They were pretty sure how to do it, so that's great. But now, here's the way that I would kind of have expected you to do it. And I say expected not because, like, I'm checking up on you and making sure you do it. It's just, I don't know, it's what I would have expected. The slope was negative 1/3. I'm sorry, negative 3. I don't know where 1/3 came from. There it is. And we're going to plug in the point negative 1/3. So y is 3, x is negative 1. And now we're going to simplify this, okay? So y minus 3 equals negative 3 times x plus 1. Y minus 3 is negative 3x minus 3. If I add this 3 over here, these 3's both cancel, and I get y equals negative 3x, which we already knew. So the answer is y equals negative 3x. And if you're like, well, wait a second, what does that have to do with this? This is the equation of a line that is parallel to this one, but goes through this specific point. So one last time, this line right here, y equals negative 3x plus b, it's parallel, but it doesn't necessarily go through that point, okay? So that was, if that was confusing, sorry about that. We'll try another one. So here, we want the equation of a line that goes through this exact point and is parallel to this line. Well, you know what? If this line were solved for slope-intercept form, it'd be a whole lot easier to look at because I could find the slope pretty easy. So I'm going to add x to both sides. I'm going to divide by 3 and get that. So theoretically, I could do this. Y equals 1/3 x plus b and plug in this information. I don't have to do that. I could just instead do y minus y1 equals m times x minus x1. Plug in that point, use that slope. So here we go. Let's do that. Y minus 4 equals 1/3 times x minus 6. Now, if they had said write it in point slope form, we'd be good to go. But I know the answer. They want it in slope intercept form, okay? So let's simplify this. Y minus 4 equals, we're going to distribute this 1/3. 1/3 x minus 2. Add 4 to both sides, and we get y equals 1/3 x plus 2. That's it. Y equals 1/3 x plus 2. Determine if any lines are parallel or perpendicular, explain. So let's zoom in here. For line A, what we're going to do is start at this point and rise and run over to that point. I'm checking the scale of my graph real quick. It's counting by ones, because check this out. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay, we're good. So that's our scale. So here's what I'm going to do. I'm rising 1, 2, 3, running 1, 2. So A's slope is 3/2. And I'm going to erase this just because that was kind of annoying. And then let's do line B. Here we are. I'm going to rise -2. So for B, it's -2 over 1, 2, 3, 4. So that's -1/2. Well, A and B are not parallel or perpendicular. So, okay. And then last but not least is line C. And if you're like, why did he do, this blue one and then this red one? Honestly, just because I was looking at A and then B, and then this one's at C. So I just went A, B, C, okay? I'm going to rise 1, 2, 3, 4, 5, run 1, 2, 3. So line C's slope is 5/3, which means none are parallel, the slopes are different, and none are perpendicular to each other because the slopes are not negative reciprocals. And if you're like, what the heck is a negative reciprocal? I didn't say it at the beginning of this, but perpendicular lines, there's two ways I remember this. They have super opposite slopes or negative reciprocals. And if you're like, what the heck is that? If I had a slope of 3 and I were to ask you, what's the opposite of 3? You might say -3. And I'd be like, yeah, that's negative. But what's the super opposite? And you might be like, well, why don't we flip it upside down? Yeah, that's it. The negative reciprocal of 3 is -1/3. So let's try another one. If I have 7/3, what's the negative reciprocal of it? -3/7. If I have 1/2, what's the negative 1/2? How about that? -1/2, what's the negative reciprocal of it? 2. Because isn't 2 over 1? Flip that upside down, take it from negative to positive, and boom, you get 2. Okay, that's enough of that. Determine which are parallel or perpendicular. It's like the other one where we need to find the slope. So, in case you don't remember, y2 minus y1, x2 minus x1. And I kind of just did those in my head because really, here's all you're going to do. 3 minus 1, that's 2. You can do that in your head. 0 minus -2, that's 2. So that slope's 1. 4 minus 1 is 3. 6 minus 4 is 2. Last but not least, 1 minus 3 is -2. 4 minus 1 is 3. So check it out. These two are negative reciprocals. So then the question is, blank are parallel, and it's none, because the slopes are all different. And in fact, wait a minute, it was the same thing back up here. Yeah, you're right. What a coincidence, right? And then right here, it is lines B is perpendicular to C, and it's because the slopes are negative reciprocals. And if you're like, wait, what? We talked about negative reciprocals right here. And these two are negative reciprocals of each other. Number 8, determine which lines are parallel or perpendicular or not at all. Well, I think I said it before, but it's real easy to tell what the slopes are when you're in this form. So for example, the slope of line B is 4/3. Like, that's how easy that was. This guy, I'm going to solve for y. So I'm going to subtract 4x. Going to divide by -3. Now, by the way, I personally would not have even cared about that part because it's not relevant to our slope. But hey, I'm here for the people. So the slope of that line is also 4/3. Okay, we're on a roll so far. These two lines are parallel to each other. Last but not least is this one. Drop my pen. 4y plus 3x equals 4. 4y minus 3x plus 4. Divide by 4 to get negative 3/4 x plus 1. The slope of this is negative 3/4. So check it out. Parallel to each other, perpendicular to each other. How do I know that? These are the same, these are opposite. And really, so this would also be perpendicular to that one, right? So, anyway, the parallel lines are A and B because the slopes are the same. Let's see, line C is perpendicular to A and B because the slopes are negative reciprocals. Equation of a line that passes through that point and is perpendicular to this line, okay? Well, the slope of this one is negative 1/5, so the slope of the new one, the new slope is going to be positive 5. Y minus y1 equals m times x minus x1. Y minus 10 equals 5 times x minus 7. Y minus 10 equals 5x minus 35. I'm going to add 10 to get y equals 5x minus 25. Another perpendicular one to this line goes through this point. It's perpendicular to this line. Well, like I've said before, it would be nice if this was in slope-intercept form, and it is really close because all we have to do is divide by 2, and our slope is 4. Our new slope is negative 1/4. Now, y minus 3 equals negative 1/4 times x plus 3. If you are lost, here's what just happened. I did y minus y1 equals m times x minus x1, and I plugged in the slope that we had right here. I plugged in here and here the point that we had right there. And then I even simplified this to be positive because it was a negative, right? So just save some steps. Now I'm going to distribute the negative 1/4, and I'm going to add 3. So let's see, y equals negative 1/4 x. If I owe you 75 cents and you give me, hang on, negative 0.75 plus 3 is positive 2.25. They probably want me to write that as a fraction. So let's see, that's 2 1/4. That's 9/4. So y equals negative 1/4 x plus 9/4. I'll bet you could type it in different ways. Like, I bet that's still an okay answer. But anyway, I'm going to type this in and see what happens. It worked. It liked that one. But this is technically right also. Okay? Okay. Modern life situation. City water department is proposing the construction of a new water pipe. The new pipe will be perpendicular to the existing pipe, which is shown, and it is passing through. Okay, so they've given us everything we need to know. New pipe, it's going to be perpendicular, and it will go through that point. The two pipes will be connected at their intersection. At what point will the two pipes intersect? Well, let's find out. The slope of this line, doing rise over run, we're going to rise up 1, 2, 3, 4, run 2. So the slope of this line, I was about to write y, m equals 2. So the new slope will be negative 1/2. And we want to go through this point. So y minus 0 equals negative 1/2 times x minus 1. Y equals negative 1/2 x plus 1/2. Okay, so let's go over here, see if we can graph it and kind of get lucky on where will they intersect, right? You never know. So positive 1/2 is right there, and it's going to go up 1 and back 2. So here we go. We're going up 1, back 2. There's the new spot. Up 1, back 2. All right, let's see if I can draw a line on this thing. Like that. All right, so it appears that it crosses right here at negative 1, 1. Now, I want to be exactly sure that I'm correct, so I would plug that in here, and technically I would want to plug it into this blue equation too, but we don't have a blue equation, so let's at least plug it in here. Negative 1, 1, so x is negative 1, y is 1. 1 equals negative 1/2 times negative 1 plus 1/2. If you're confused on what's going on right now, I just took this x and I plugged it in right here. I just took this y and I plugged it in right here. Okay, so 1 equals, well, negative times a negative is positive 1/2. And guess what? 1/2 plus 1/2 equals 1. So that is definitely on this green line. Let's go with it. They will intersect at 1, nope, at negative 1, 1. Right, that's what I wrote right there. What happened? Let's describe the error. Write an equation of a line that passes through that point and is perpendicular to that line. Okay, well, before I even check what they're going to do, actually, I already see the problem, because the first thing I'm going to do is I know the new slope should be negative 3. And I can already see right here, they didn't do that, right? That's a positive 3. They should have done a negative 3. Let's just see if they did anything else wrong. There's the y, it's correct. Here's the x, that's correct. Let's see if they did anything else incorrect. That should be positive. It is 3x minus 12, that's good. They subtracted 5, yeah, it's just that they jacked up the slope. I shouldn't just say slope. New slope should equal negative 3. Come on, man. The vertices of a quadrilateral are 2, 2, 6, 4, 8, 10, 4, 8. Woohoo. Is the quadrilateral ABCD a parallelogram or a rectangle? Okay, well, to perhaps make it easier, we could graph this thing just to kind of help us think through it. I don't know if that's 100% necessary, but I'm going to do it because it would be nice to see that there's A, and then B is at 6, 4, so 3, 4, 5, 6, 3, 4, right there. C is 8, 10, so we're already at 6, 7, 8, 10, okay. 5, 6, 7, 8, 9, 10. Way up there. That's C. And then D is 4, 8, so there's 4, and then 8 is right here. Okay, well, I think we can all safely say this is not a rectangle, right? Because rectangles don't look like this. Now, remember, this isn't a perfect picture, but if it were rectangular, I mean, do I really need to draw a rectangle here? Here's a rectangle. Like, that's what a rectangle looks like, right? If we were to even try and rotate it, I mean, that ain't it, right? Do I have a parallelogram? What do? Here's a parallelogram, right? Notice kind of the shape that it can kind of shift and change into and things like that, right? So what if we took that? What if we were to rotate this one? I mean, let's be honest. It kind of looks like that, doesn't it? But we're not going with kind of, because what if it's none of the above? What if they are all wrong? So we did this so that we can check. And if you know me, you know what one thing I'm going to do is go AB, I'm going to find that slope. So AB, 4, 2. That is a rise of 2, because 4 minus 2. And then 6 minus 2, that is 4. So the slope of that is 1/2. Okay. Well, if this is going to be a rectangle, then BC, this line out here, should be a negative reciprocal. I don't think it's going to be, but we're going to check anyway, right? So BC, 10 minus 4, that's 6. 8 minus 6, that's 2. The slope of that is 3. This is not a rectangle. Nope. So, and why not? Because these would have to be negative reciprocals of each other, right? So let's check this out. We need this, by the way, because this slope needs to be 3 in order for this to be a parallelogram, right? Because opposite sides are parallel. So let's check that now. I can't erase. There we go. So AD is what we're checking. 8 minus 2, that's 6. 4 minus 2, that's 2. 6 over 2, that's also 3. So check it out. This is 3, this is 3. This is starting to look like a parallelogram. Let's check out the last two. DC. All right, DC is here. 8 minus 10 is negative 2. Uh-oh. 4 minus 8 is negative 4, which turns out to be 1/2. This thing is, yes, it's a parallelogram. Determine whether the statement is always, sometimes, or never true. Two lines with positive slopes are perpendicular. I mean, that's never true. Why not? Because they need to be negative reciprocals, which just, if one slope is 3, the other one has to be positive 1/3. I mean, this one's positive, this one's negative, this one's positive. So they can never have the same sign of slope. And the last two, you're designing a new logo for your math club. Your teacher asks you to include at least one pair of parallel lines, at least one pair of perpendicular lines. You sketch the logo below. What are the equations? Okay, so, all right, let's check this out. I'm not even going to look here just quite yet. Let's just check this out. This is definitely a vertical line. Its slope would be undefined, which, if you think about it, that would mean it's like 3 over 0. And if you're like, does it have to be 3? It's infinite over 0 technically, because it's, it's vertical, and anything divided by 0 is just going to be undefined. So these two are undefined. Oh, I guess, you know what, we could get a little bit more specific with it. This line is x equals 2. This line is x equals 6. Okay, so let's check that out. The parallel lines are x equals 2 and x equals 6. Okay, I like that. Oh, I see. We're not even thinking about the circle. The circle's just trying to throw you off. And then the lines that are perpendicular. So hold up, by the way. It's this one, because none of the others even have correct answers for the parallel lines. But just to go ahead and do this, this slope is 0. That slope is 0 because it's completely flat. And it is the line y equals 4. If you're a little bit lost on y and how I got x and y and stuff like that, there's Vux and Hoy. Vertical lines have an undefined slope, and they are x equals a number. Hoy is horizontal lines, 0 is the slope, and it's y equals a number, like that. Okay, next. Determine whether the statement is always, sometimes, or never true. Explain your reasoning. Two lines with positive slopes are perpendicular. I feel like we just did this 2 lessons. So the statement is never true. So here, it's either this one or this one. Let's check out what they said. Perpendicular lines have opposite slopes, so one must be positive, the other must be negative. That's not bad, because perpendicular lines have opposite reciprocal slopes, so one slope must be positive. Ooh, this one is the better answer. Okay, it's this one. And if you're like, wait, why? Because this one, like, just says, hey, they need to be opposite, but it doesn't mean that they're super opposite, which is what I said way earlier, where I said, like, wherever I said that at. Think of it this way. Opposite 3 to negative 3, that's opposite, but super opposite is a negative reciprocal, 3 over negative 1/3. So there's the whole thing. Let me know what questions you got over parallel and perpendicular lines. See ya.